shell?
Just now, the
All using the vertical strips. Among the using horizontal strips doesn't work for every method, for every situation.
well, you not always get a ring, or you don't always get a disc, right?
Oh yes, so.
But any shape can be think of as union of layers.
Yeah, yeah.
Pesan ini disampaikan oleh Humas Pemda Kota Bandung. Memasuki musim hujan, PT Kereta Api Indonesia Daerah Operasi 2 Bandung
Yeah.
So
mewaspadai
the
sejumlah
interesting one,
titik
like
rawan bencana seperti tanah
computing
ambles,
the
longsor,
volume of
maupun
a
banjir.
donut.
Humas PT KAI Daops 2 Noksi
So can
Citerang
you
mengatakan
realize
untuk
the
mengantisipasi gangguan perjalanan
the
kereta
donut
akibat
as
bencana alam saat musim hujan, pihaknya
as
telah
the result
menyiapkan
of
sejumlah personil dan fasilitas pendukungnya.
revolving
Erlangga
something?
Suparno Hadisaputro melaporkan,
Well,
Noksi
of two things. I mean,
secara intens
What?
if you
sekaligus menangani
if you
daerah
think of it
rawan
as
bencana.
using those horizontal strips again, then that's
No,
the,
first
the outer one.
just geometrically, how do we get the donut out of what? We rotate what around what?
Something blank and then a strip.
Something blank? Strip? No. How?
Well, I mean, it's a strip distanced from the axis of rotation.
You just need to rotate a circle, right?
What? Okay, yeah, okay, you can do that. Well, I was thinking of like a strip and it's distanced from this axis of rotation.
But there is no part that is really
And then you just add them on top of each
rectangular.
other. Oh yeah, okay. Yeah, yeah, circle. Circle. Okay, a circle that's distanced from the axis of rotation.
So it actually that is a good exercise for applying the symmetry on the integral, because the integration is kind of bad, but if you look out the some even function or odd function, then it can be simplified in computation. So what the apa kau tidak mau? So what? So can I change this thing into two? So bad. So like this. Oop, two. Bad.
You know, I can't read on the road.
Just imagine then.
Imagine what? A circle.
Circle and then
Rotating it.
So if you slice circle,
In what way do we slice
it's
this?
vertically. So
Vertically.
if you want to use the shell method, we always slice so that the axis of rotation is
Perpendicular, parallel.
parallel. Yeah. parallel to the slice.
Okay, I can see that.
So like if we just
Ada wooden drum ya. Ternyata.
what are you doing? Shit. Okay. But we're gonna take the half of the donut, right? Like we only rotate the half of a circle
Why?
because this is the same the bottom one.
Okay.
So this is of radius r, and then the what? The radius of the circle is little a. So it's gonna be r minus a, and this is r plus a. Then we take a slice like that. Right. And then we rotate this guy.
Okay.
So what is the equation of the circle? There's a circle of radius a, and then where the center is at r comma 0. Right?
Okay.
So then what?
X minus
X minus r squared plus y squared
equals
equals
a squared.
goyang equal to a squared. Okay, and then what? So this guy we take okay, so of distance x, right? So the height is gonna be, so this is y is equal to square root of what, a squared minus x minus
R squared.
r squared.
Yeah.
Okay, so when we have this shell, yeah, so it is of height, this guy, and what is the radius?
It's
It's
R.
x. It's x, right? Because we take
Oh yeah,
the
yeah,
slice
X, yeah.
of distance x. So then the delta v is gonna be. So if we cut this shell, we're gonna have something like this. Oops.
Yeah, okay. Strip.
And the length is exactly the circumference of this guy.
Which is
This what?
2 pi r.
2 pi x.
2 pi x.
So this is 2 pi x, and then multiply by this guy.
Yeah, okay.
X minus r.
Also, we have. Oh, so the x that it's depending on is the same, so we can integrate that.
From where to where?
What? From the batas-batasnya is r minus a and r plus a.
Yeah. So the volume is, this is half of the volume.
Okay, yeah.
Half of the donut is the integral from r minus a to r plus a
Of x.
2 pi x.
Oh yeah, x.
Right. But this thing is can we what What do we get if we do substitution x minus r? So let's say z is equal to x minus r.
Fair point.
Then when x is equal to r minus a, the z is starting from what?
Huh?
Yeah, if we use substitution z equal x minus r,
Okay, and then x equals r
Then-
minus a. All of that.
so,
is
so
for
the z
division.
starting from
Minus a.
minus a up to
A.
a. And here we have 2 pi z plus r. And then this oh, it's bad. Okay, so the volume is gonna be integral from minus a to a 2 pi z plus
plus r.
r square root of a square minus z square. Easy. Now look, this is very what? Suspicious. Right? So is this what kind of function? Is it an odd, an even, or none?
What? I can't see.
This square root of a square minus z square.
Well, what's the? Is a constant? Oh,
yeah,
a is a constant.
it's
Yeah.
constant.
It's going to be an even function
Even, but if you multiply with this guy,
with z plus r.
just with this the z only.
Okay. Yeah, that's it's an odd function.
It's an odd function.
An odd
So
times
when
even
we, so
is-
when we multiply this 2 pi z with this thing, we get an odd function.
Yeah. Okay.
So this can be thrown away.
Yes.
So basically we just integrate 2 pi r
Yeah. 2 pi r times
times
our square root radical. Nah, pulpen no anya na pakai.
this one, only one.
Oh yeah. Does this one work?
No,
Oh, it doesn't. Oh, enggak.
2 pi capital R. But how do you compute this kind of integral?
What? I don't know.
Huh? Well, sometimes you just need to interpret it in a geometric way. So if we pull this 2 pi r outside,
Okay.
so this is what? This. Geometrically, it's describing what?
What?
This thing, this expression.
It's describing
Describing what area?
the area of a what? Yeah, the curve of a square root function.
So if you have y equals to square root of a squared minus z squared, and if you square both sides, what do you get?
Y squared equals a squared minus c squared,
Which is?
which is a what? Oh, is this the Pythagorean theorem?
Yeah, what kind of curve? Y squared equals to a squared minus z squared. If you move the z squared to
The
the left hand
circle.
side, the circle.
Yeah.
So what? This describing what kind of area?
That's the area of. Well, I still can't envision it.
Huh?
Okay.
So then you know this thing is y equal, this is a circle. It's half of a circle.
Yeah.
Top
okay.
of it. And then you integrate from minus a to a.
Mhm.
So this guy is nothing but this.
Well, the area of that circle.
Yeah. Half of the circle of radius a. So then we don't really need to calculate the integral. We just use the the formula for the area of the circle.
How come it works like that?
Huh? Well, because we know it is true that the area of a circle is something. So then this thing is what? Then half of pi a squared.
Yeah, okay. Eh,
So,
1/4. Kan A na. Wait a second, enggak si A na radius, okay.
so this is then what? Pi squared r a squared. This is half of the donut.
Yeah.
So the full donut is twice of this. That's the volume of the donut.
What? Well, that's pretty.
Okay, this is interesting. The thing that the what the integral looks intimidating, but after you do the what the substitution, then
Okay.
it's behaves nicely.
But I still don't get the jump, the leap from this part to this.
Because if you do anything like this,
Yeah.
and this is y equal fx, then the area is the integral from AB of fx dx.
Whereas tadi,
Before, this curve is y equal to a squared minus x squared if you want.
yeah.
Because this is the positive part of the circle. The part of the circle with a positive y.
Yeah, okay.
So if we replace the f of x by this one, and the bounds from minus a to a, that's exactly the area of this.
Oh. Okay. Except we use z. I mean, is that not gonna affect anything? Oh, but z is x minus r. So,
Yeah. So
oh,
like,
it's just for a circle. Except we. Oh, it's because we have this radius, right? I mean, it's a donut. So when we evaluate this a squared minus c squared, then it's pretty much a circle. However, our
why we just like introduce a new axis, which is the z-axis.
Yeah. In which that axis starts at that point. I mean, it's not this one. I mean, it's not this one,
Yeah.
because we're separating it by r. So when we substitute x minus r with z, that's just saying
You shift the
we shift the center of the circle. Oh, okay, and then in terms of that newly shifted circle, then when we okay, I get it now. Then integrating this is pretty much saying.
But actually, you don't really need to rely on the geometric intuition. So whenever you have something like this is the z is just dummy. You can replace with anything.
Pokoknya it's a variable.
Yeah, it's a variable.
And this expression in which whatever variable the z is.
And then if you're more comfortable with x, you can switch it back to x.
Okay. Okay. Then pretty much this just indicates that is the area under the upper part of the circle's curve.
Yes.
Oh, yeah, that is true. From minus a to a, curiously, because that is our bound for this particular circumstance. Which is interesting, because then that turns this into the half of that.
Sometimes when we have a difficult integral, we can do the opposite. So usually we compute area using integral, but sometimes if we already recognize the area of a certain object, we can interpret the integral as area without calculating explicitly the integral.
Oh, okay.
Like the example on the one of the exercise, like
I don't know. I don't believe
something like this one, for example. Well, you cannot calculate this integral.
Oh,
You
that
need,
one. Okay, I
need to
remember that one.
interpret as
Yeah, as area,
area.
geometrically.
Is there any comment here?
Nggak tahu. Ayo nonton kita.
When the tutor will be begin? I don't know.
Terbab 4.
Lumayan killing the time. Sometimes
Lumayan. Though it's hard to envision things. Okay.
What is
This.
this? New one?
Yeah.
Okay, here is Bandung, saudara-saudara semua. Jadi kita perlu keluar pakai Grab. We look each other if we just what? Looking at the eyes.
My hair is better.
So it is interesting to think of what kind of object that we already know the volume of, like, and then can we recreate or reprove the formula, pyramid, or what else, the sphere.
Bingung deh, cari tempat prawedding yang pemandangan alamnya bagus, tapi nggak mau jauh dari pusat kota. Gimana ya?
Angkot saling dago.
Sebuah villa strategis yang terletak di area dataran tinggi kota Bandung dengan spot pemandangan Bandung yang keren dan udara pegunungan yang sejuk adem. Cafe View Bintang
Should try this one, Akam.
dan outdoor yang cocok
No.
untuk prawedding.
View kaku.
Mau buat jelema.
Juga gathering event. Gathering kenalan, Cafe View Bintang punya lebih dari 10 spot foto yang bisa bikin kamu makin eksis.
Ya betul, Alvesha.
Area Pasar Iwan Gadung Bandung. Untuk informasi dan reservasi hubungi 081324908787 atau follow Instagramnya @cafe_view-bintang.
Ini buat mahasiswa ITB yang belum pernah ke Bandung. Jadi ini situasi jalan Dago. Sebentar lagi ke Jalan Dago.
Tapi belok ke kiri.
Kapan pada mau ke Bandung? Semester depan sudah masuk ke Bandung? Ini abnormal di sebelah sana. Saya kan
Nggak tahu, nggak pernah. Pernah sekali.
baru lihat kan
Bukan beda.
Tommy.
Nggak ikut ini. Aku mau sama teman sekolah.
Amin. Si ibu nonton tak?
Nggak tahu.
So the difficult one like this one, the volume of like the intersection of between the two pipes. it through. I don't know. Ramai tapi lampu hijau. Oh, kita belok ke kiri.
Ke kiri.
Kalau ke ITB mah belok ke kanan sana, saudara-saudara yang belum pernah ke ITB. Belum bawa. Kita belok ke sini, ada macet.
Kalau mobil gini pagi-pagi mah nggak sempat ini sih, pagi-pagi berangkat ngantar si Hanif. Si Hanif waktu turun di dia
Wah,
kan nyebrang naik angkot terus tapi suka jalan sendiri.
kering kenapa? Kering kenapa? Kering sana.
Di landmark Bandung kan atau itu yang nggak ada. Akan di konser.
Oh, ada Bandung Mantur. Pernah naik saya.
Ada konser
Oh,
tuh.
ada Henian. Nambah nih kan? Bangkrut gitu. Tuh Komsel.
Padahal tempat parkirnya bagus.
Hah? Jangan terlalu lama. Itu ya? Ya, masuk saja. Oke, kita